Okay, so we did the Friedel-Crafts alkylation reaction in the end of the last class, where we have seen that by this reaction we are able to substitute the alkyl side chain to the benzene ring.
Yes.
And now we are going to see the mechanism, but first, before mechanism, we have to see, as the examiner can also ask you for the formation of electrophile. So we will see the equation that how the electrophile can be formed in both of the cases. So formation of electrophile. The equation is almost same as we did for the formation of electrophile in halogenation and chlorination and bromination. If you will see, you will understand. See, for first case, we have a alkyl group having CH3, CH2, which is bonded to a chlorine, right?
Yes.
And there is a halogen carrier or electrophile, which is anhydrous AlCl3 or anhydrous AlBr3. So what will happen over here, that chlorine with its lone pair makes the dative bond with the aluminium and breaks this bonds heterolytically. So as it breaks this bond heterolytically, it removes as a chloride ion, and when that chloride ion joins with AlCl3, a negatively charged ion is formed with the formula of AlCl4 negative. And the leftover species is CH3, CH2, and as chlorine takes away the electron of that carbon as well, so that's why this carbon now possesses a positive charge and it becomes a carbocation. And as we know that it's an electron deficient, so it is the electrophile. As if you recall or see, the Cl positive and Br negative are formed as the electrophile in the halogenation, in the chlorination of benzene, and in the bromination of benzene. So is this equation is understandable to all of you?
Yes, sir.
Yes, Kubra?
Jason.
Yes, Hassan? Yes. Now, if you look at the second reaction, the other reagent is this alkyl halide. Right? So this alkyl halide also reacts with the anhydrous aluminium chloride in the same way by forming a dative bond from its lone pair and breaking a bond with the carbon heterolytically and takes the electron of the carbon as well. So it becomes a negative ion, and that negative ion, when joins or bonds with AlCl3, turns into AlCl4 negative, and the leftover hydrocarbon chain becomes an electrophile it because one of the carbon is now electron deficient, as it's one of the electron is taken away by the chlorine. So this becomes an electrophile. Is this clear?
Yes.
Yes, Kubra?
Jason.
Okay. Now, mechanism for both of the reactions. So we have a benzene ring, and the electrophile formed is CH2CH3, where that CH2, the carbon bonded with the hydrogen, with two hydrogens have a positive charge. So that face of the electrophile or the alkyl carbocation actually faces the benzene ring due to the high negative charge density of benzene ring. So this positive space or positive side of the electrophile is attracted towards the benzene ring. Now, what will happen? Benzene will attack this positively charged carbon from its pi bond, and as a result, an intermediate is formed, and in that intermediate, now this electrophile alkyl chain is now bonded to a carbon, and we know that all of these carbons have one hydrogen with them. And we know that two of the electrons from the pi ring system is basically provided to this alkyl chain. So the pi ring system is disturbed for the time being. So we will make the half circle and the positive charge to show this intermediate. Now what will happen? Carbon breaks the bond with the hydrogen heterolytically and takes the whole pair of electron and provided to the pi ring system. As a result, the pi ring system restores alkyl chain, substituted the hydrogen, and our product is formed. But at this stage, the negative ion that is formed along with the electrophile is also there. So the hydrogen ion that is released interacts with AlCl4 negative, and as a result, that AlCl4 negative releases the chloride ion which is bonded to it, and that chloride ions bonds with the hydrogen to form HCl, and the catalyst AlCl3 is restored. Is this clear?
Yeah.
Yes, Yusuf?
सर प्रोडक्ट हमेशा हर रिएक्शन में सेम होगा?
Which product? See, this product is always going to be different depending upon the electrophile, but these two are going to be the same.
Okay.
For example, if you see here, this is another alkyl benzene and this one is a different alkyl benzene, but we are always getting the HCl. So that is same, but this organic product is not same. It depends upon the alkyl halide that we are using as a reactant.
Okay,
Is
sir.
it clear now? Yes, Kubra, is it clear?
जी sir.
Yes, Maham?
Yeah, it's clear.
Yusuf? Okay. Now, let's have a look at the mechanism for reaction B, where there is a longer chain alkyl halide. So we have a benzene ring. Now the carbon which becomes positively charged faces benzene ring. And if you see, it is the carbon which is on the left. So what will happen? Benzene ring again attacks this carbon as it's an electrophile electron deficient with the pi bonding system. As a result, it disturbs its pi bonding system for the time being, but that carbon gets bonded to the carbon of the benzene ring where there is a hydrogen present, and the disturbed pi system is shown by the semicircle and the positive charge. Now carbon breaks its bonds heterolytically with the hydrogen and provides the whole pair of electron to the pi bonding system. And as a result, our organic product is formed. And the hydrogen ion releases from here, interacts with AlCl4 negative. As a result, chloride ion is released, and that chloride ion bonds with hydrogen ion to form HCl, and our catalyst for the reaction is restored. Yes, is this clear to all of you?
Sir, what is AlCl for?
Sorry?
What is the AlCl for? Is it catalyst?
See, if you see, this is the catalyst, AlCl3. In the first
Yeah.
step, it turns into an intermediate, and then at the end, that intermediate interacts with the hydrogen ion that is released to, and catalyst is again restored. So AlCl3 and hydrous AlCl3 is the catalyst.
Oh, okay.
See, in the equations, we have mentioned these, not the negative ions, because they are formed as an intermediate, and then catalysis is restored. Is it clear?
Yeah. Yes, sir.
Yes, Kubra? Yes, Hassan?
जी सर
Yes, Yusuf? Okay. Okay. Now, next we have we are doing electrophilic substitution in benzene. First, we did it with chlorine or a bromine with halogen. Then we did it with alkyl halide, that is Friedel-Crafts alkylation. Now, third we have Friedel-Crafts acylation. So, in this reaction, acyl group. And what is acyl group? Acyl group is an alkyl chain bonded to a carbonyl carbon. That is acyl group. Okay.
Yes.
Substitutes the hydrogen of benzene ring In this reaction, now we have used acyl group. So acyl chloride is the reagent, as we have to substitute the acyl group. So the chloride will remove again in the same way and joins with AlCl3 to form AlCl4 negative, making the acyl group electrophile. So in this reaction, acyl chloride, and what is acyl chloride? Acyl chloride is the alkyl chain bonded to a carbonyl carbon, and that carbonyl carbon is bonded to a chlorine. Reacts with benzene in the presence of catalyst, and that catalyst is anhydrous aluminium chloride or anhydrous aluminium bromide at higher temperature. So first have a look at equation. We have a benzene ring and acyl chloride CH3, C double bond OCl. Okay. The catalyst is anhydrous aluminium chloride, or we can use aluminium bromide as well at high temperature. So what will happen? That chloride removes from C double bond O, hydrogen removes from benzene to form HCl, and that carbonyl carbon gets bonded to benzene. So what is the functional group over here in the product? Yes, what is the functional group in the product? It's benzene, it's ethanoyl chloride, and if you see in the product, there is a C double bond O, and that C double bond O is bonded to a carbon to both sides, which means it's a ketone, and that ketone is named as phenyl ethanol. Is this equation is understandable to all of you?
Yes.
Yes, Kubra? Okay, now formation of electrophile. So that acyl chloride reacts with AlCl3 first, where chlorine forms a dative bond with the aluminium, as aluminium is electron deficient, and breaks the bond with the carbon hydrolytically and takes the pair of electron from the carbon, becomes a chloride ion, and when that chloride ion bonds with AlCl3, AlCl4 negative ion is formed, and the left behind group becomes, that carbon becomes a positive charge, and that's why it becomes an electrophile. Is this understandable?
Yes, sir.
Okay. Now, let's move to the mechanism now. So, we have a benzene ring, and that carbon with a positive charge get attracted towards the benzene ring due to the positive charge on it, and benzene ring have a high electron charge density. So benzene attacks this carbon from its pi bonding electrons and provides 2 electrons to that carbon, 2 bonds with it. As a result, its pi system disturbs and carbon gets bonded to a carbonyl carbon of an electrophile. On each carbon of a benzene, there is 1 hydrogen. The disturbed pi system is represented by drawing a semicircle with a positive charge. Carbon breaks its bond hydrolytically with the hydrogen and provides a pair of electrons to the pi system. As a result, hydrogen is released, pi system is restored, and that acyl group gets its place bonded with the benzene ring. So the hydrogen that is released interacts with the intermediate AlCl4 negative ion, which was formed in the formation of electrophile. As a result, it releases the chloride ion. That chloride ion bonds with the hydrogen to form HCl, and the catalyst is restored. Yes, is this understandable to all of you?
Yes, sir.
Yes, Kubra? Okay. Now, I have a very small task for you guys. Write chemical equation then equation for the formation of electrophile and mechanism for the formation of Yeah. So first you have to write the equation. Then you have to write the equation for the formation of electrophile. And then you have to draw the mechanism. And here the equation, formation of electrophile and mechanism are available for the reference. So do it quickly. Maha and Kubra, you are going to WhatsApp me and I'm going to check both of yours. Yes, done. Yes, Maham and Kubra.
No, sir, I'm doing.
Okay, if you are done, please share. देखिए एग्जांपल का एग्जांपल किए क्यों नहीं? जो मैंने करवाई है वो क्यों नहीं? ये ऊपर वाली का है जब प्रैक्टिस नहीं करोगे तो करा मुझे तो बाद में ऐसी लगती है Maham, I am waiting for you to share. Why you make it CH4 Kubra? Keep it as it was. Maham, how much you have done?
Yes, sir, I'm sending now.
Okay. I am waiting.
Sir, I couldn't work out the mechanism properly.
Okay, till here it's all fine except the electrophile you made. Let me show. The rest of the things are correct. Good efforts. Okay, Kubra, pay attention. So see, if you see that from here they are bonded to each other, right? So it means when I make the reactant, I will make the reactant in the similar way. Just put a Cl over here, that's it. From where it is bonded to benzene, at that place I need to put a Cl over here. Yes, Hassan, did you understand? Yes, Kubra, did you understand? Now, Cl and HCl from this acyl chloride and H from the benzene is released to form HCl, and that C double bond O is now bonded with the benzene ring. Is this clear?
Yes,
Yes,
sir.
Kubra. Yes, Kubra, did you understand this? Yes, Kubra, did you understand? Now, for the electrophile, see, I just flipped the molecule. It reacts with AlCl3 it provides its lone pair to the aluminium, which is partially positive, and breaks the bond with the chlorine. Now, Maham, the mistake which you did over here is this, that you made a bond over here. Now there will be no bond over here because the chlorine is removed. So only this is the carbon which becomes partial positive. So we will draw it like this. That is the only mistake that you did. And AlCl4 negative is formed. Yes, is this clear?
Yes, sir. Okay.
Yes, Kabra, did you understand?
जी सर
Yes, Hassan? Yes, Yusuf? Now, when we move towards the mechanism, benzene ring, show that positively charged carbon facing towards benzene ring. Benzene attacks from its pi bond to that carbon, and as a result, that C double bond O carbon is bonded to benzene ring, and there is a hydrogen. The pi system disturbs. It breaks the hydrogen and provide the lone pair to the system to restore it. And here the intermediate negative ion interacts with the hydrogen ion, which is released to form HCl, and our organic product is also formed. Is this clear?
Yes, sir.
Okay. Yes, Kubra. Yes, Hassan. Yes, Yusuf. Okay. Now, after this, the fourth electrophilic reaction is nitration of benzene. Benzene reacts with concentrated nitric acid in the presence of concentrated sulfuric acid, which is a catalyst at 25 degrees Celsius to 65 degrees Celsius temperature range. And for that, we do reflux. And here in this reaction, nitro group, nitro is NO2 group, displaces hydrogen of the benzene. So it means NO2 becomes the electrophile with a positive charge. Displaces hydrogen. And the product form here will be or is nitrobenzene. So let's have a look at equation. We have a benzene molecule it is reacting with nitric acid, which is concentrated, and we used or added concentrated sulfuric acid, which acts as a catalyst. Temperature is 25 to 65 degrees Celsius. Reflux. So from HNO3, NO2 group substitutes the hydrogen, and that hydrogen comes out from the benzene, joins with the OH to form H2O. So that is equation. Is this clear to all of you?
जी sir.
जी सर
Okay. Now, formation of electrophile. So, nitric acid reacts with sulfuric acid, and as a result, NO2 positive ion is released, H3O positive is formed, and HSO4 negative is formed, and this NO2 positive act as a electrophile. Now, mechanism. We have a benzene ring and NO2 positive. So benzene from its pi system attacks the NO2 positive. See, if you look at all the mechanisms are exactly the same. The only difference is the electrophile only. Now, it releases the hydrogen, introduces the pair of electrons to restore the pi system. And here, the HSO4 negative, which is formed from the catalyst as the intermediate, interacts. Nitrobenzene is formed. The hydrogen joins with HSO4 negative to form H2SO4. So see, the catalyst is restored. Yes, is this mechanism is clear to all of you? Yeah, all the mechanisms are same. The only difference is the electrophile in all of these mechanisms. Yes, Kabra, did you understand?
जी सर
Yes, Maham?
Yes sir. Yes.
Okay, so here we have completed the benzene, and in our next class we are going to start with phenol, inshallah. And in the next class, our next class will be on Monday, and then we will discuss about the classes that I have to, the compensation classes which I skipped last week. Okay, so we will discuss about those classes and we'll schedule inshallah in the coming week. Okay. Okay.
Sir.
Any query or question you guys want to ask?
No sir.
सर जो आपने क्वेश्चन कराया था मुझे वापस समझा दें
Which one? This one? So see, if you see, we have to make this, right? So if you see that benzene is bonded to this carbon, right? The C double bond O carbon, this carbon. So For the equation, what we will do, we will break this. We will make the benzene, and to this carbon, we will bond a Cl. So we got the other reactant. Is it clear now?
जी सर.
So when the reaction occur, chlorine from here remove, a hydrogen from here remove, they both join to form HCl. And as they join to form HCl, now from the carbon where the chlorine is removed and from the carbon where the hydrogen is removed, these two carbons bonds with each other. See over here. And we got this product. Is it clear now? Yes,
जी सर.
Kubra? Okay. Now, if you see the formation of electrophile, isn't it same as all the rest of the electrophile formation that we were doing in that we did in the previous class and that we did in today's class as well, except the last nitration, right?
जी.
And then if you see the mechanism, isn't it the same? What I just did, I flipped this because
जी
I
सर.
have to show the positively charged carbon facing towards the benzene ring over here. Yes, anything else you want to ask?
Okay.
Okay.
No sir.
So,
Clear है.
okay, that's fine. So we will be ending the class over here. And in the next class, we are going to start with phenols on Monday. And on Monday, you guys, please remind me. So I will schedule the 2 extra classes, which we left in the last week. Okay, then take care, everyone. Have a good night. Allah
Okay.
Hafiz.
Allah
Allah Hafiz,
Hafiz.
sir. Take care.